Okay, if I could now introduce our next speaker, Stuart Thompson. Stuart is Senior Design Manager for Morgan Sindall. He's leading the design team for the University of East Anglia new low-carbon enterprise centre. This is a development with very strong environmental credentials, and it's pioneering its approach to the use of local materials, supply chain engagement, implementation of soft landings, and the inclusion of life cycle effects. So thank you very much.
Thank you. Thanks for staying. I might start off a bit slow, and then I'll speed up. Hopefully I won't crash when I get to the end. This is the project that I'm going to talk to you about. It's an absolutely incredible project. I don't believe there'll be one like this for a long time. You can see on the first line of badges there where Morgan Sindall sits with as the single point deliverer in our design team, which is Archetype, BDP, Bisria, Churchmans, Bidwells, and, would you believe, the Master Thatcher of East Anglia. So you don't get many of those projects, and you can see below the badges of the funding stream. So I'm not going to dwell too much on the project. Obviously, to contextualise what we're talking about, I am going to set the scene of what the project is, so you get a feel for it, and then I'm going to go into what we're doing life cycle-wise, because that's why we're here. Okay, so the NRP Enterprise Centre, it's supposed to be a world-class building, a gateway to the university and a showcase for sustainability. So some quite big aspirational words there. The single point delivery team, headed by Morgan Sindall, we put this team together. I've gone through who they were. The client set us these 7 employers' requirements: 100-year design life, passive house, BREEAM outstanding, low embodied energy, local supply chain, renewables, soft landings, post-occupancy evaluation. None of those are a surprise on their own, but all on the same building is quite incredible. We lovingly refer to those as the Magnificent Seven. So where the project is, the red blob is the site. The buildings at the bottom of the screen, that's the main campus of the University of East Anglia. So the road coming down from the top of the screen is leading into the campus. Hence they wanted a gateway building into the campus. This is the site at the moment. So it's just some derelict buildings at the moment. This is our master plan. Our building is down here at the bottom of the screen, and that's the master plan for the whole area that we're developing to make sure that the building fits in. Our building is at the top of the screen there, and you can see how the building kind of nestles in to what we're proposing for the master plan for the wider area. So coming back to local materials, when we started the tender, which was about a year ago now, we started thinking what materials were local to Norfolk and East Anglia. That's where the building is. And we were looking at the reed and the straw, and you can see where the thatch is coming in. We were looking at chalk, we were looking at lime, we were looking at hemp, we were looking at all of the local natural materials that were available in the region. Timber being a big one. The green dots are on the map of East Anglia are the forests. There are lots of private estates, and of course there's the Forestry Commission with the biggest government estate there. And the client had already spent some time looking at local timber, and this is a report that they had produced. How can we use local timber locally? And at the moment, the timber is very low grade, is used for pallets and fence posts. So the idea was, could we use that timber in a different way? Well, we took that on board, that report. The report wasn't part of the employer's requirements, but we were aware of the report. And we started thinking, well, maybe our structure should be lightweight. If our building is lightweight, then perhaps we can start looking at timber. We've borrowed the Brestapole idea, which is the picture there, and we've gone into the forest, and this is our design team selecting the logs that we've now got at this moment being tested at the BRE in their timber laboratories to find out what we've got and how can we use that. In the press at the time, a year ago, was our thatch, or was articles on thatch and reed, very much important to our region. So we started thinking about using thatch in a different way. Maybe that's something. So we came up with doing thatch differently. And the idea was, if we were really going to do thatch differently, perhaps we could take away the hazard of doing it on the roof. So we came up with the idea of using panels. Perhaps we could panelise some kind of thatch system. And then we thought, well, if we panelised it, then we wouldn't necessarily need to do it in season. So this could be out-of-season work for the thatchers, controlled in a barn. I quite like that as a builder, that I've got something that's now controlled at ground level, so it's safe. I can keep an eye on quality. So this is starting to tick a lot of boxes for me. Our biggest problem is how to get the Thatcher's dog on site. So you can see the Thatcher's working away. That's me watching him. That's why he's working so fast. And you can see our first trials of the panels. The panels are kind of looking quite good. And this is a finished sample. The Thatcher, this is a corner. So the Thatcher's not that pleased with it. I mean, we were thrilled. We thought this was marvellous. But we've got some more work to do to tidy this up, get the thatch denser. This material was grown on the other side of the trees in the background there. So you can't get much local than that. We're keeping our carbon miles down. So these ideas were really coming together on this building. And you can see how these are the artist's impressions. We're in planning permission as we speak. Hope to get planning permission received next month. So as you can see, we've got a thatch, vertical thatch, off-site construction with the UEA logo embossed into the thatch there. This is our signature building, the gateway down to the university. Now this stamps of low carbon, doesn't it? So you can see how the building is shaped, shaped like an E, E for enterprise. It's very handy. We've got two wings. One wing is for low carbon businesses and the other wing is for low carbon teaching at the university with a lecture theatre in the middle. You can see looking head on the two wings with the gleaming white cube in the middle of the courtyard. You can see where we've really embraced the low carbon approach. These are just some views from the rear of the building and some views looking into the building. Okay, so that's kind of, now you got an idea of the project. Now we're very lucky because the client is, as I hope you can imagine here, is very progressive and is really interested in all the ideas that we've got. So when we started looking at lifeCycle, of course originally it was for BREEAM outstanding requirements. I mean, that's being very honest and just saying that's what we need to do it for. But we had our first workshop and we thought to ourselves, hold on, there's something in this. You know, this really is quite interesting, and the client was very keen to understand a bit more as well. And we as a design team wanted to look more in depth at the life cycle. So part of our reality checking and soft landings really helped us to kind of get this over to the client. You can see a timeline here, which is roughly a year. You can see what we've been working on, where our REAP stages have fitted in. We started off quite formalised with the DQI process, which is quite a formal approach with stakeholder engagement meetings. This worked really well to kind of get things moving. We complemented that with the BISRIA soft landings framework, which kind of brought in a bit of informal discussion as well. And that has been really helpful for fitting in lifeCycle. It's gone in really well. lifeCycle, the first workshop, was kind of a high-level approach, is to looking at the things that we really wanted to take forward. And then the second time we looked at lifeCycle, this time it was with the client. This was part of the reality checking process in soft landings, so very much fitting together. And we were also able to revisit the project values that had been set, the Magnificent Seven that had been set to us over a year ago. So part of the life cycle was to bring everything back together again and say, are we making the right decisions? Recently, or up until last week, we've been working on value engineering options for the client, and we've been very fortunate that the life cycle, we held the life cycle workshop with the client at the right time. I'll come on at the end of the slides, you'll see why that's been important, because it's really helped to put some reality into the value engineering debate that we've been having. So what have we actually done? Well, we started off looking at what the university already has on campus, and we lovingly refer to this as the good, the bad and the ugly tour. So we went round and looked at some of the good things that worked, some of the spaces that the client and the university liked. We started looking at the materials and started looking at why they liked them and how they worked for them. We started looking at some of the things that were a bit ugly, that didn't quite work as well as they had hoped, and they didn't really like it. And this was really good to understand where the client drivers were. And then we started looking at some of the ugly things, some of the things that kind of come in at the end, like bins and switches and stuff that just appear everywhere. That was really useful and really helpful to kind of enable us to start thinking, well, what do we think their drivers for life cycle would be? What do we think as the design team? Because first of all, the design team sat down and thought about it. This was a REBA stage B, C review, that type of time, so it was done to be able to give us enough options to kind of change our mind if we needed to. And it was just held with the design team and the life cycle consultants, which was BISRIA. We started looking at the wider picture issues, and we settled on these. We wanted to compare just a normal Partel building compliant design with the passive house design. Just wanted to see overview, how did that look. We started looking at the different types of energy sources which would be available, from gas to district heating, anaerobic digestion, air source heat pumps, things like that. We want to look at the different types of what would we do with overheating. Should we go for the mechanical ventilation, which was the requirement of passive house? Should we up the thermal mass in the building? We've got a timber building, remember, so that's going to add some cost there and add some weight. We'll think about that. Landscaping materials. We thought, well, let's look at some of the simple things, the landscaping, the things like the slabs and the resin bound gravel and stuff like that, which always has been a bit of a problem for estates departments, particularly gravel and stones and things like that. So for us, we might think there are bigger things to think about, but for the estates department on campus, that actually was really quite important. So we'll pick on something that's important to the estates guys. Then we looked at glazing, look at the amount of glazing, and then of course the trouble with glazing is that if you put more glazing in, whilst it looks great, then in comes the solar gain, so now we need to deal with that. So glazing just as a kind of square metre is not so much an issue, it's what then happens after the glazing. So the headline issues from the report was that the client team were able to send us some information on management costs, maintenance costs, and their utility and recharge out rates for their energy units, which was really helpful. These were just headline figures, and from our point of view, we were able to input some actual build costs into the process. So that helped with the assessment. Various tables and figures were produced, which we could all look at. The headline one with the energy source, or looking at the passive house versus the Partel, which is what the graph shows. As you can see, the one on the left, the blue is a bit bigger, which is the build cost. So for a passive house building, the costs were slightly higher. That's perhaps not a surprise because of the higher specification that's required. The maintenance costs, the red blob, were similar to a Partel compliant, but of course the energy in use was dramatically reduced. Now this was obviously sort of year one analysis. Now if we do the life cycle on that, however many years you want to do it for, it's pretty obvious, isn't it, that the blue and red are going to stay the same, and for however many years you want to do that, because the green bars are so different, over 40, 50, 60, 100 years, we're modelling this on 60 years for BREEAM compliance. That made a huge difference. So we were able to demonstrate that what we were doing from a capital cost point of view might be slightly more expensive, but from a whole life cost point of view, the client was on a winning streak. We debated the options after the stage one report on what we would take further, because we couldn't do everything. We started to really get excited in the workshop about how many different things we could analyse and how many different things we could try and review. But to be honest, we felt we would get bogged down, so we thought we'd better handle a few things and do a few things well. So we came up with just a simple table, and what we thought of was looking at the energy source. That was very important, particularly as the university has a district heating main already on site. Now the new building is not intended to be connected to the district heating main, but of course it could be. So it's an interesting debate here whether we have the building as a standalone with gas, for example, which passive house and gas work very well together, or whether to try and bring in some other form of renewable. We looked at the overheating. We decided that was one to take forward. PV and roof covering. The client is very interested in PV and the way that PV works and how it works. They already have several solar arrays on campus which they're monitoring. So this was something that was very much in their knowledge base. So we felt, well, we'll look at that with the client. Windows, we learned from the good, the bad, and the ugly walk round with the client that actually windows keep falling out of their units and actuators don't work and things like this, and they're not as robust as they claim to be. So we thought, well, hold on then, let's have a look at windows for the client. Landscape materials, we kept looking at. Lighting was number 7, the different types of lighting, playing the difference between LED lighting and traditional fluorescence. And the last one was floor finishes, looking at the different types of floor finishes. So those were the ones that we thought we debated and we thought we would carry forward. Now, as part of the soft landings process, we decided to reality check a few things. So we picked on the obvious one, which was M&E. It's a very hard one to do. There's hard deliverables there. Everybody knows what they want from the FM team. I want this type of air handling unit. I want this type of boiler. These are the controls I like. So, you know, there's some very firm beliefs there from the client team that we can work with. Then the lifeCycle one gave us options. So that was kind of a bit more of a discussion and a bit more of a debate, which we liked because we were able to give them data, and the client really likes data to be able to chew the fat over. So we thought, great, this is an opportunity to give them data and have a really good discussion and debate. And then at the bottom there, we were very fortunate to have Wolfgang Feist, the founder of the Passive House design concept, to join us for a design team meeting where we very much worked on the softer side of things. And Wolfgang's advice to us, which was great, was it's just got to, the big word was comfort. If the building's not comfortable, doesn't matter what you've done. It just has to be comfortable. And we really like that as kind of an ending point. So you can see where lifeCycle came in. So it's really been part of the process all the way through. So session 2, this time with the client team. So that fitted in around November time last year, just going back to that slide. And obviously your clients like a workshop. So there we are, having a workshop with David, young David down there, and Peter, with their spreadsheets, death by PowerPoint, I think that was again, and death by Excel as well. And we had a really good day. I mean, there was incredibly good take-up from the client. We got the right people in the room. We were able to ask questions. We were able to really reality check what goes on. And the best thing was, taking your point earlier about these guys were telling us exactly what happens at the university. And we had the guys there, when we started talking about windows, we said, right, timber windows, aluminium windows. So now we're playing the cost idea, we're now playing the carbon idea. We like the idea of timber windows because low carbon, so we're thinking that's a way to explore. But our friends in the estates department said, I'm not going to maintain them. I have no budget to maintain them. So David had to quickly change his table and say, well, when are you going to maintain them? When are you going to look at these windows? When are you? And they said, never. They said, well, really? And they said, at the moment, there's no budget. And that's not a criticism. That's just factual and real knowledge, which was hugely important. So he said, well, hold on a minute. In that case, we need to halve our life cycle expectancy of these windows. So that was very real data, very open and honest communication, which actually was extremely valuable because it changed the way that the outcome came from the reporting process. So out came report number 2. So report number 2 was at stage D, so therefore we had some pretty good information to be working with. We had really good attendance, open and frank discussions with the team, which was really good. So we looked at those items that I mentioned earlier, and we reviewed them all with the client team. The report was finalised, and the outcomes were debated in the later value engineering sessions. So the headlines was that the client was able to bring, now they had, between lifeCycle report 1 and 2, they knew what we were doing, and they went back and really analysed their energy costing information for us. So when they came to this second workshop, they brought with them real information. They knew what we were doing it for and why we were doing it, and they had gone away and done some work, a lot of work themselves, and came to this meeting and changed the figures that we put into the lifeCycle spreadsheets. The client was then also came with climate data. Now, fortunately, very fortunate that at the University of East Anglia is the Institution for Climatic Research. So if anybody knows what's going on, they do. And they were able to bring real information for our building on our site. So our building, from a climate point of view, has information really that no other building has. It affects what is going to happen to our building over the future years. And of course the FM team really came with their maintenance regime, realistic maintenance regime, said this is what's going to happen, guys, this is where our budgets are at the moment. And that was really valuable information to be able to put into the reporting. So, and from the contractor's point of view, we had already been out to our marketplace with our stage D design, and we were able to feed back information on the roof, the PV, the windows, the landscaping materials, and the various bits of the lighting strategy, and we were able to feed all this information into the lifeCycle work. So the conclusions and the recommendations of that report, was a nice table in the back of the report, nice and simple. If we take out all the ones, and then if I wipe those out, you can see for each case down the left-hand side, you can see the energy source, building overheating, roof covering and PV, window frames, landscaping, lighting and floor finish. You can see we've got the best option from a life cycle point of view, which worked for us. So we were then able to take that information, present it in a final report and present it to the design team and the client. Now these are not obviously then agreed to go into the project. What they are is something that informs us all and helps us to make the right decisions later on. Now you're going to ask me about the carbon. So I knew that was coming. So the architect, archetype, they have a program called the Rapier software, and their Rapier toolkit was being used alongside the life cycle costing information to just have a check on the carbon and what was going on carbon-wise, just to make sure we weren't making any massively dangerous design changes to our low carbon approach. So of course we're looking at the things that we know. Hemp is on the top, then we've got our thatch, and then we've got our local timber. Feeding that into a graph, this graph shows where we've got carbon expenditure on the top of the line and sequestered carbon within the materials that we're using underneath the line. And of course the idea is to make those balanced. They'll become a carbon sink. Carbon sink might be a stretch too far, but low carbon is what we're aiming for. So this is taking, where do we fit in? This is taking some industry standard data. You can see where offices are, and you can see where a typical further educational building is at around 150 kilograms of CO2 per metre squared. At the moment, our design is at 168. So that's a fraction of what a typical further education building. So I think we'll have met the target low carbon. Of course, we're not satisfied with that. We need to go lower. So the idea as we move into stage E is to keep mindful of what we're doing from a carbon point of view as well and get that even lower if possible, of course. So that's been really useful that the life cycle costing has kind of been first, and we're following shortly behind with the life cycle carbon so that we've got those bits of information to work together. Looking at what that means, the carbon, what does it mean? Well, on the top graph, the red line going across the bottom, it shows that's the carbon that's expended when we build the building. And then the two diagonal lines show the embodied carbon or the carbon used as the building's in operation, and what the payback times are. And the vertical drop-down line on the top graph shows that after about 7 years, our building will become carbon neutral, whereas a typical building, could be around 37 years. So, that's a massive improvement there. So the benefits then, the benefits to the project to date, because obviously we're only, well, a short way through in the lifespan of this project. So we're taking our two reports, and what we did was at a Valor engineering meeting, if you remember the slide a few moments ago. Obviously there is a capital cost issue, we're all aware of that, so we need to balance everything together. So we had a workshop, and these guys at this workshop were the decision makers, and that was very important. We had the director of estates, we had the director, the project director, we had the guys there who would actually make the decisions that we needed to make at that meeting. And we looked at the floor types and the finish, the roof walls and types, the windows, heating and lighting, amongst other things, you can imagine, but these are the big ones. You'll notice things like M&E and stuff like that, I've not mentioned, but that's because we felt that we would be doing that anyway. We don't want to just do the norm. Value engineering and reviewing the M&E package is something that we would do on every project. So if we just put that up here, then we're not doing anything differently. So we thought we'd do that one anyway. So we wanted to pick on other things. And what was a real success is that using the life cycle information, we started to debate the floor. The current or the original design was a timber floor. And then we said, well, if we changed it to a concrete floor, what would that do? From a life cycle point of view, that's really good. In fact, we put our concrete floor in, and it works really well. In fact, a saving of £65,000 we kind of thought would be available there. Now the client has taken that forward, and that's based on the life cycle cost and the life cycle carbon. I'll come on to the carbon in a minute. The roof and the wall cassettes, we looked at those. We looked at trying to do something a bit differently. And we started to say, well, if we change the materials, it would perhaps change your specification and your scope a little bit, Mr. Client, but thinking of life cycle and thinking about the longevity of these things, going back to our reports, which were on the table, this is something that we really wanted to introduce, and the client liked the idea, and we went ahead with that. The windows, we had a massive debate. The client was very keen on timber windows because obviously the carbon issue there, and wanting to have local timber, that would have been the real win. But of course the estates guys were saying, well, I don't like timber windows because they're not going to be maintained properly. I'd rather stick with something traditional, the aluminium windows. So the halfway house is alley composite, aluminium windows with timber. And we looked at that, and the life cycle carbon ended up pretty good. The life cycle costing ended up pretty good as well. So again, it's helped us to make decisions. We looked at the district heating main, and we balanced the gas, or gas only, district heating main, district heating and gas, anaerobic digestion, solar thermal, air source heat pumps, all the usual, and we looked at those, had the reports on the table, and we made a decision. We're going district heating main. We looked at lighting. Now, of course, we wanted to, the issue with lighting, of course, is the LEDs are more expensive, so we're not going to see a massive saving by switching to LEDs from the capital cost point of view. But looking at the long-term issue, there could be savings there. And we looked at the life cycle reporting, which BISRA had done, and again, the client has decided that's something that we want to take forward. So that was real life cycle in practice. So you can see from that table, 4 of those we've absolutely taken forward based on the life cycle information. And again, you're going to ask me, well, what about the carbon? Well, we looked at just a couple of these to be able to say to the client in the same meeting, what about the carbon? So we looked at a timber floor with a kind of lino floor covering on top. And we said, actually, there's negative carbon. There's the bar at the top. It's negative carbon for the timber floor, or timber only. Then you look at, well, actually you need to sand it, seal it, kind of things like that, so that will add a little bit of carbon. So you can see that's the next bar down, adding a bit of carbon. Then we're going to stick a carpet on top and look at the carbon impact over a 100-year lifespan this is. So this is replacing the carpet every 3 years, things like that, and having to clean it and maintain it. All of a sudden you can see, well, holy smoke, it's the carpet that's the problem. Then you go the next one down, well, let's try a different type of carpet. Let's try nylon, or let's try lino, or something like this, and the carbon is just running away with itself. So then we thought, well, let's just compare it to concrete. Well, of course, on the left, there's our timber floor, which is carbon negative, and then the ones on the right are our concrete floor. So you can see at the bottom, there's perhaps your traditional concrete, just straight out the wagon. Very huge carbon expenditure there. But if we started, making it a bit more environmental, putting in 20% GGBS and maybe 50%, maybe even going industry leading and head up to 85%, then all of a sudden the carbon starts to come down, but there is still a carbon expenditure compared to timber floor. Well, what we then did is we thought, well, let's put them together. So we're now saying timber, carpet, everything else, maintenance all together. Or what we could do is we could just have concrete, polish the surface, and that's it. Model this over 100 years. And these here are ranges. So we've got timber at the top, which is, as you would expect, carbon negative, which we all accept. And right at the bottom, massive carbon expenditure is a nylon carpet slapped on top of a traditional concrete slab. So you can see massive carbon expenditure. But in the middle there, in the middle bands, you can see that's with no floor finish. So if we didn't have a floor finish, all of a sudden carbon doesn't become that bad. The concrete doesn't become that bad from a carbon point of view. So now we're taking that forward and we're thinking, well, now let's look at the concrete as a specific item, and can we actually do something else? And we're now looking at perhaps the opportunity, or we're now looking and do some testing of making concrete floor slab with no cement in it. The silence I thought there would be. I mean, there's where the carbon is. The carbon is in the cement. So this is really market leading. So it's now taking the carbon element from understanding what's in the concrete and doing it differently. So that's where we got to. That was just before Christmas. So I'm going to finish off now. So far, then, to date, has the life cycle benefited the project? Well, there's been some negatives, and there's a lot of information to digest, as you all know, from everything that you're doing. Which is right? Who knows? It's really difficult to get our heads around all of this. a multi-headed client has appeared. So now we've got FM guys on one side, we've got estates over here, we've got the registrar who's holding the coins on this side, we've got the director of the low carbon who's on this side. So all of a sudden, it's like, who do we listen to? Because we want to listen to everybody. So that's kind of a little bit difficult to manage. And then, of course, there are endless options, really. And when do we stop? I mean, at some point, we do have to move into detailed design and then build the thing. So at some point, we're going to have to say, we've made a decision and we're moving on. So that's kind of been quite difficult. Maybe negative's the wrong word there on the screen, but it's been difficult or challenging. But on the positive, though, from where we are to date, and of course, we haven't started detailed design yet, we've really enriched the project values. Going back to the Magnificent Seven, we really believe that we've really understood what the client is after here in this building, what this building is intended to be. We really helped, the life cycle has really helped to provide realistic value engineering and not just looking at the capital costs on its own. It really has helped, and it was really encouraging at these meetings, which were this year in January, to be able to always refer back to, but remember at the life cycle workshop, and that was really interesting. The client has a real appreciation of what the life cycle means. I mean, they think they know, like everybody, like we all do, but until you actually really do it and really look at options on a project, I'm not sure if we do. And so I think that the client has really learned a lot, and I think the client is really interested in the next 3 years POE, but way beyond that, the next 5, 10 years, and monitoring the decisions that we've made and seeing how they kind of pan out. We have a very well-informed project team. We're making decisions, we're having information that's available to us all, and hopefully we're making the right decisions.
Okay. Thank you ever so much. Well, Stuart, I think that was a great case study showing the practical implementation of life cycle costing and other issues within the UCE building. I think it's lots of great things come out of it, including, I think, how the life cycle costing work has led to a more engaged client and a more informed project team. So that's very good. Questions for Stuart?
Ralph Moore from Serco. A couple of things. You started off at the beginning talking about all the various local materials. I got the impression towards the end through the workshops that you've actually moved away from that in terms of some of the materials you're now using. Is that correct?
Moving away, I can see where that perception has come from. Yes. So the key materials, things like the thatch and the hemp insulation and stuff like that, is grown locally, and no, we haven't moved away from that. The timber has been the real issue for us, trying to use local timber. We're not moving away from that, but we are having to accept that maybe it's a step too far, not from a life cycle point of view, from an actual structural point of view, on what we can do efficiently as well. Because sadly, we're not geared up for that in the UK. On the continent, it's different. They're geared up for doing things this way, but that's not the case in the UK. So what we've started to see is that there's a lot of inefficiency in what we're doing. So I would need to fell a tree, I'd need to cart it somewhere to be dried, I'd need to cart it somewhere else to be milled, I'd need to cart it somewhere else to be cut and shaped, I'd need to cart it somewhere else to be put together, and then I'd need to cart it to site to erect it. Whereas in Europe, that's all done in one building. So there is inefficiency in the UK system, which is what we're starting to see. And that doesn't mean that we can't do it for a proportion of the building, but perhaps not all of the building. And the idea is if we don't do it, then it will never happen. So the idea is we want to retain that and be able to say to the industry, this is a piece of timber that's, say, come from Europe, a timber beam, say a glulam, for example, and next to it is a timber beam that's come locally, and try and put on there and say, this is the difference in cost, this is the difference in carbon, and why that is and what happened, and see if we can change the way that the UK deals with its timber. The UK doesn't grow timber for structural reasons. The UK hasn't got the right climate. There is an element of it, but not for the commercial timber market, for structural market, for what we need in building. But that doesn't say that that can't happen in the future. But unless you start kicking that process off, it's never going to start. So our kind of aspiration, if you like, at the beginning, that that 100% of the timber would be local. You're correct in saying that that's starting to diminish, but not to zero. Yeah. We're going to still retain as much as we can.
Yeah, and you mentioned, obviously, your throwaway remark almost about having concrete without cement.
Yes.
I mean, are you talking about lean mix or?
No. We are talking about we're talking about taking cement replacement to the next level.
Oh, right.
And I can't go into any more detail than that because we're testing at the moment to see if it will work. If it does work, then there's another case study which I'll be presenting. But if it doesn't work, then there's a learning exercise there to say why it didn't work and what needs to happen in the industry. But from a program point of view, we would have to revert back to something like, a very good environmental reinforced concrete design, but using traditional methods.
And are you incorporating insulation in that to improve the
Yes.
U value
Yes.
performance?
Yes. Well, I mean, the U values, the thermal performance of the building is really determined by the passive house requirements, which, roughly speaking, is 0.1 all the way around. So yeah. With regards to the insulation, it's kind of trying not to go down the petrochemical-based route and looking at the bio-based products that are available, hence the hemp, the driver for hemp in our region.
Thank you.
Okay, another question.
Isn't 60 years a bit excessive for something that's going to burn down after about 3?
Well, yeah, I was waiting for someone to say that. Thatch building on the university campus with a rugby team on a Saturday night.
But maybe on a more practical note, you can build the thatch panels in a factory. How about replacement?
Yeah, I mean, just to kind of quash the thatch thing, I mean, naturally it was an issue when we first thought about it over a year ago. We sat in the architect's practice and he said, well, what materials are available locally? What about thatch? And me as a builder, Morgan Sindall, said, not on your life, mate. But then on the train back home, I was thinking, well, why would I say that? So that's when I got in contact with the master thatcher of East Anglia, and we started talking about thatch and our concerns being, fire being the main one. And you start really looking at thatch and thatch fires and how they occur and what happens. And I won't go into the technical details, but the idea with our panels, I mean, we have had workshops with the fire brigade, building control, with the building insurers, with everybody. And it's in planning at the moment with the planners and planning, and would you believe not one comment from anybody has come back about that. You'd expect it from the fire brigade and the architectural liaison officer for a start, but I think we've engaged with them so much that it's okay. The idea is that by building your thatch panels off-site, by doing them at body level, if you like, is that the thatch is compacted so tightly that a burning ember can't get in. And if it got in, there would be no oxygen for anything to burn. The reason why thatch fires occur on properties is sources of ignition from your chimney flues and things like that land on the thatch. The thatch is quite poor quality, that it burrows in, it has oxygen, and that's how the fires occur. This is different. There's no source of ignition. The thatch is raised above ground floor level, so that should help. You can't light it with a cigarette lighter, but if you were to light a wheelie bin, for example, and pull it up against there, what would that do? That's the reason why it's been raised high. So there's lots of passive security and things like that. We did think about, could we spray it? Should we spray a retardant on it? That type of thing. And no, I mean, there's a carbon impact of that. The Thatchers say there's no point. So it's kind of, I think we've covered the fire thing quite well. From a carbon point of view, I mean, it's just an incredible material. We didn't want to go down the use to using reed because there's a limited supply of reed, and reed is used domestically. So we didn't want to sort of take the entire supply of reed from the domestic market and upset, all the homeowners in the region. So that's why we've stuck with local straw.
Okay, well, thank you very much.